Chapter 4, Jets. The F-35 is advertised as the most complex, most competent, most advanced multi-role joint strike fighter ever produced. At a purchase price of $180 million US per airplane, plus maintenance, the total program cost is calculated to be 1.5 trillion US dollars, making it more expensive than constructing all the Egyptian pyramids in adjusted currency. In fact, that makes it the single most expensive project ever undertaken by humans on Earth. The World Health Organization says 1.5 trillion United States dollars is enough money to feed every person on the planet for 50 years continuously and end world hunger. What happens when businesses and organizations and governments develop an attack or a defense that prevents the F-35 from completing its missions? All that $1.5 trillion sits idle until the F-35 program can deploy a countermeasure. In the world of global defense, these moves are attempted all the time, every week, continuously. How fast do the world's militaries want to design, develop, test, and deploy new countermeasures? Really, really fast. $1.5 trillion worth of fast. We don't get to talk about most of our work with the F-22 and F-35 programs, but we can show you pictures with signed releases taken from in Joe Justice's house. Here we see the head engineers from Boeing and Lockheed Martin for the F-22, the retired 3-star Air Force General, Ken Merchant, who helped the F-22 project at the time and now heads the F-35. A leadership team member for the F-35, the US government procurement officials responsible for purchasing the F-22, and the government organization responsible for auditing the purchase process to verify it is in the taxpayer's best interest. When we talk about full stack teams that can responsibly make decisions inside the team without waiting on external approvals, this is what we mean. This, by the way, is why an agile transformation is a leadership activity. It involves the policymakers of the company to sign a new policy and fund it. Now, you can do agile without a leadership team. You then have a voting mechanism, share-based or percentage-based, or everyone has an equal vote. And in the case of co-founders of a startup, that's normal. And everyone then votes. So the leadership function has to endorse an agile transformation. In the case of a company that's not flat, like the US Air Force or Boeing or Lockheed Martin, the leadership team has to endorse it to create a full stack team. When these professionals run the build exercise, they don't need to fold paper airplanes. They are so good, they can use metal and carbon fiber. In the pictures below, you can see these teams with a car they built in a similar amount of time to what most companies use conducting the airplane game. That car was phenomenal. You can also see awards and challenge coins from Boeing Commercial and Military, Raytheon, Lockheed Martin Space Systems, and Lockheed Martin Complex Systems, the F-22 and F-35. Most of this work we cannot discuss in detail, but here we can share that whatever work we may have done together was appreciated enough that we were honored with awards at award banquets and award ceremonies. Raytheon publicly announced their agility in radar systems in their investment portal to attract new investment due to their modern and fast-moving agile practices. So that at least can be shared. I've turned off my background to show you an award shelf. I actually took these out of storage to film this. I used to have them in my classroom, but right now I'm primarily online. So I sold the classroom. These were in storage. I took them out. So here is a model F-22 that was sent by Ken Merchant, retired 3-star general who now leads the F-35 program, with a beautiful note from Ken saying he endorsed me. You can see Ken wrote an endorsement for me on LinkedIn. Here is a Nürburgring Nordschleife plaque from me being co-captain of the race team at the Nürburgring. Here is a 3D printed Toyota Way from the early agile manufacturing operations in Toyota, from when I was working with financial services at Toyota North America, and the stamp and die system for the 2019 Camry and its aluminum roof. Here is an award from Boeing. Boeing builds something faster. That came from my collaboration with Boeing Military and the new model aircraft for Boeing. Here is one of the first test bucks, we call it, for the Wikispeed SGT-01. It's been battered and beaten. Maybe you can even see the paint's cracked. That's what the first car, actually it became the second car, looked like. This was a miniature model of the same CAD that we then made full-size a day later. Here is a pin from the North American International Auto Show, the largest auto show at the world that time, where he exhibited on the main floor. An award from Big M and the Society of Manufacturing Engineers for delivering a keynote there. An award from Carnegie Mellon for guest lecturing there. An award from Jazoon, the Java conference in Zurich. An award from John Deere for my involvement in the S-Series Combine. Pens from Rockwell Collins, which has now become Rockwell Aerospace. Gold and silver coins from Lockheed Martin Complex Systems and Lockheed Martin Space Systems. Royal Bank of Canada, 3M, the Aspen Institute, the F-22, and Raytheon. Just to show that this stuff is real. Yes, I'm proud of it. I am proud of it, and this is a chance to share it. But practically, I could say also it's to validate and provide evidence that, yes, this work has been done. Yes, Agile is happening in these companies. Please use this as evidence of Agile transformations in large projects in case you need it. Agility is not only modern, it also has a long history. Agile aviation, where high quality and speed of design productivity go hand in hand, is not new. When it's been needed, engineers and designers have operated at incredible speed. For example, in 1940, the P-51 Mustang, argued to be one of the very most effective planes of the era, was designed and the first prototype built in 102 days by North American Aviation. The inspect and adapt cycle is at least as old as 1620, with the articulation of the scientific method by Francis Bacon. In the some people will say, Sir Francis Bacon. I try to avoid monetary and oligarchy awarded titles. I don't mean to be weird. I would love to be a sir, but I'd rather just call people by their name so we can give attribution as opposed to titles and entitlements. I don't think that's the focus. In the 1930s, physicist Walter Shewhart of Bell Labs began applying Plan, Do, Study, Act, PDSA cycles to improve the design and provision of products and processes. In Saab Aeronautics, the 353 of Scrum has been used since at least 2007. Here is the executive and head of the structures group for another multi-role joint strike fighter, the Saab Gripen. They're wearing the blue jacket here as we're outside and it was chilly. There was light snow actually at the time. Jürgen Fulhelm with Joe Justice in the middle and the author of the book Scrum for Hardware, Paolo Samachelli. Joe and Paolo were allowed to write about what they learned there. Joe published a research paper, Owning the Sky with Agile, and recording an interview with Jürgen Fulhelm, both of which are available online. And Paolo Samachelli recording the learnings and analysis and this truly is a landmark book, Scrum for Hardware. And you can see the book here. There's even a free preview on LeanPub. That book is phenomenal, and it's now in version 2 as of this recording. I hope it goes even to version 10, but as of this moment, it's in version 2. Scrum for Hardware by Paolo Samachelli. Paolo is a genius. I hope more people, he's very well understood, very well read, very popular. I hope even more people find Paolo's work. The Gripen is built in iterations, with cross-functional Scrum teams owning modules of the aircraft. They report Gripen teams have been implementing Scrum from at least 2007, iterating from the Gripen A variant to the B, C, D, E, F, and now even M and autonomous, unpersoned. They accomplished this by having 8 full-time pilots on site, working with all teams as needed during the 3-week sprints. While Paulo and Joe were on site, the teams were incorporating a new jet engine. This one was purchased from a supplier, and they accomplished the entire integration within the 3-week sprint. This was accomplished by designing a wrapper, an interface that adapted the inputs and outputs and mount points of the purchased jet engine to the inputs and outputs in standardized locations within the fuselage of the Gripen, the Saab Gripen. Jürgen Fulhelm explained, the architecture of the plane is like interlocking toy building blocks. They can be pulled apart and new blocks attached to the same mounting points very quickly. Please see Chapter 10, XM, Extreme Manufacturing, for more detail on modular architecture for speed in agile companies. Reconfigurable means we can add applications without having to requalify the platform. We can even change hardware without affecting the overall application layer. Johan Suggetoft, project manager avionics platform for the Saab Gripen, Linköping, Sweden. We don't know what the fight will look like in 30 or 40 years from now. To ensure that we have a fighter that is still relevant, we are building it so we can easily upgrade it and use the latest and best technology out there when it comes to hardware and algorithms. Marcus Want, test pilot, Saab Gripen, Linköping, Sweden. The pilots fly the aircraft at sprint review at the end of each sprint. The dramatic enabler for Saab was negotiating with their certification authority to not require recertification of the aircraft when they make software and some types of hardware changes. This cannot be stressed enough. A long-running certification process, in some cases years, limits each sprint length to a minimum of several years. No product can be released to market, the purpose of a sprint review, unless it meets the tests and certifications required for use. Working directly with the testing organization, in this case, the certification organization for aircraft, the Gripen teams achieved an agreement to maintain the existing certification and not wait through the lengthy previously required certification process. How and why was this responsible? Saab Aeronautics and Saab Defense agreed to run every certification test themselves every 3-week sprint internally. Most of these tests are run virtually and continuously through simulation software. Saab invites the certifying officials on site each sprint during sprint review to verify the aircraft is still compliant. This enabled continuous certification and 3-week sprint rollout of an enhanced aircraft. Again, for those who would like to learn more, please see Paulo and Joe's publication specific to the Gripen noted in the bibliography. Also, Paulo's book, Scrum for Hardware, talks about more. Every test that was required for certification was run in simulation constantly on whatever the most recent CAD and code that was checked in. So there is a full simulated aircraft flying through in simulation, all required aviation tests. And that simulation is running in emulation the actual code that's checked in. By never stopping that program, and their teams constantly updating it to have higher correlation with reality, and by flying the current planes every 3 weeks or more often to check correlation and make sure the simulation is updated, the simulation was so good, the certifying officials could just use the simulation and do spot reviews. Also, because they're approving the aircraft, well, saying it's still approved every 3 weeks, the changes are not multiple years long, they're 3 weeks worth of changes. So it's easier for the auditors to comprehend the total scope of change and make a responsible continuance of certification. We should make a strong point about cost. Not only did Saab prove that they could build an aircraft with Scrum, but it is also in some dimensions the best in the world. Jane's Aviation Weekly reports the Saab Gripen is the world's most cost-effective military aircraft, saying it is not only possible to design, build, test, and deploy an enormously complex system in 3-week sprints with Scrum, but when it happens, the product can be the most cost-efficient on the planet. The leadership structure to enable this is an executive team that continuously renegotiates the purchasing contracts for these airplanes with the world's militaries as their customers. The contract is then broken down into work to do, product backlog, by the teams themselves, using sticky notes on the walls. I'd like to clarify this. The executive team, my understanding when I was there, was not dictating to teams what they need to do. The executive team was essentially sales, negotiating sales to the Brazilian Air Force, the Swedish Air Force, and others. Then they have signed contracts, and the contracts are updated continuously. The development teams themselves would identify the modules and create backlog from the contract. They would write their own backlog. And then they would provide trend lines to when it was likely to be done. And then leadership's job is to update the contracts to reflect the reality of how fast the teams are actually responsibly delivering, which is inverse to a lot of top-down companies, especially you'd think in aviation. The teams then use their velocity, the average completed and tested work across the last 3 sprints, to report back to the executive team the date toward which they are trending to meet the key chunks of the contract. The teams themselves create the detailed plan and set the completion dates. And it is up to the executive team to maintain a signed contract that matches reality. As reverse as this may sound, this method is part of why companies with Scrum teams of top executives behave very differently. And some have tremendously stronger financial results. And again, this is part of why an executive-led agile transformation is required, as the entire organization is trained to perform as Scrum Masters. It's not only military aircraft, however. Mitsubishi's regional jet, called the Space Jet, planned to have dramatically larger interior volume than its predecessor and named the Space Jet to boldly state its large interior, has run into budget overruns and near cancellations many times over. In fact, it was canceled at least once now. In the public press, this aircraft project is understood to be high risk, having difficulty getting anything done. An acquisition of Bombardier brought in some Scrum Masters to Mitsubishi, who began working in Scrum teams even without senior leadership approval or awareness. And their work began completing on time, even early. Mid-level executives requested Scrum training and requested additional teams be trained. The goal for Mitsubishi is now to save their regional jet project, even if it means restructuring the organization to work in sprints of completed modules of products. The previous waterfall plan had separated the work into phases and handoffs. In the previous plan, one organization would create the plan of the jet and a separate internal organization would build according to the plan. Many of the executives recognized during their agile training the risk of regression in the previous non-agile plan. Regression occurs when a plan is handed off to another group to analyze the plan, then handed off to the second different group to build according to the analyzed plan, and handed off to a third different group to test and build the product. And finally handed off to another organization to deploy and support the tested product. What occurs is that problems found in testing or when the product is deployed and being supported require updates to part of the planning phase and starting the process again. This had occurred too many times within Mitsubishi, making the planning stage never sign off as complete, and they were running out of money. The solution? Don't end the planning stage. Stop trying to get the plan perfect without feedback from actually building and flying with customer collaboration. Instead, the Scrum Masters in the organization are proposing each sprint plans, analyzes, builds, tests, and deploys a module of the aircraft. For example, in the Agile plan, the fuel tank is proposed to be tested on the ground and in the air in sprint on a modular test plane with stable mounting points. The stable mounting points are proposed to last into the production aircraft, allowing fast maintenance and future upgrades. In this way, the plane may be re-architected to be similar in modularity to the Saab Gripen. Boeing has also trained all the executives leading their next major commercial aircraft. This Scrum training has empowered them to choose how best to set up this massive program from the onset. That's the NMA, the Boeing New Model Aircraft. Airbus has executives, Airbus executives have built cars with Joe Justice in order to learn Scrum in hardware sprints. Airbus continues to post job openings for Scrum Masters. In aviation, commercial and military, we are seeing the market benefit. Desire for faster time to market of improvements and new capability drives Scrum Master training for executive leadership, group leaders, engineers, new hires, and even interns. The takeaway of this section, if you're teaching this course or taking this course, is this agile stuff, these short iterations, works even in the most complex systems humans know about, with hardware, software, vendors, government contracts, approvals, regulatory. Now, a sprint still means done and on sale. So we wouldn't have a planning sprint and a build sprint and a test sprint and a certification sprint. The sprint length must include all of those. So for all of these companies, the first sprint is super long. It's years long because it's to go from design, at least an updated design, at least an update of a current design, through build, test, and deploy. A sprint is a complete waterfall, including certification. Now we use technical practices to shorten that waterfall, to shorten that sprint and try to get it to less than a month. And the reason we want to do that is because of the Standish Group's data showing small projects of less than a month are enormously more successful than large projects. We'll see that data later. It's like 64% less likely to be a complete and total failure. We'll see the actual numbers soon. So the takeaway here is you can really do this. You can do this in software, you can do it in hardware, you can do it with procurement, with vendors. And the enabler is whoever makes structure of the company decisions needs to be on your Scrum team, so they can make incremental structure of the company decisions. Without that, we can sub-optimize. So let's say you're a CIO, Chief Intelligence Officer, or a CTO, Chief Information Officer, or Chief Technology Officer. You could speed up the hardware in your company because you can restructure that group, but you wouldn't be able to directly affect the hardware until the executives in charge of that, if you're in a traditional hierarchical company and still have executives, they would need to architect their transformation. In Saab, the leadership group runs as a Scrum team to get signed contracts. That enables the entire company to feel that rhythm. And they do a 3-week rhythm. When you get super fast, you don't actually need a rhythm. You can transcend a rhythm, but we'll talk about the benefits of a rhythm in a later chapter. Okay, that was chapter 4.